we can check that in the calculator. Sorry, just changed mine out. Look at that. So when we go to y equals, I'll type this one in, 5 raised to. Make sure you do alpha y equals to get your fraction. X divided by 4. Now we see the equal sign, so 30 goes in y2. I didn't mean to hit graph, I'm sorry. There's our functions though. Alright, let's go to the table. Here's where I meant to be. And I'm looking for 8.45, so I need to go to the second window. And when x is 8.45, again, that's a rounding. I've got 29.9 and 30. That means that this would round to 30. The more of this decimal I use, the more exact my answer will actually be in the calculator, but this is good. Alright, so we're going to work the next problem. Okay, sorry, didn't want to clear out. Alright, now, number 5 looks different. Every base has been a constant number, a whole number. This base is only e. That's a letter, but I will explain to you what we're going to do with it. It's not any different though for the first step. My job is still to isolate the base, and we said the base is e, so this 5, it's got to disappear. So the way that I get rid of it is to divide. So I've got 2 equals e to the 4th. Okay, now I want to show you something important before we finish this problem. In your calculator, we've got a natural log button right here, and then above it, so I hit second, we've got the e. We're going to put it to the 1 power. And when I hit enter, notice I get 1. So the natural log of e, because e is already to the 1 power, right? Just anything I write is to the 1 power, is 1. Why is that important? Right here, when you see the base of e, we are going to rewrite with logs, but we're not going to go to a regular log because I didn't have a base that is a whole number. I did not have a whole number base. So we had an e, a letter. So how we rewrite that is we're going to take the natural log of 2, and we're going to take the natural log of e to the 4x right here. Now, hopefully you remember from log properties, because we did those, that the exponent actually gets written out front. So this is really the natural log of 2 equals 4x times natural log of e. Again, that's an exponent rule from log properties. The exponent comes out front. Well, the natural log of e is 1. So it's really 4x times 1. Okay? That being said, now I just have the natural log of 2 equals 4x. So I'm going to punch the natural log of 2 into the calculator. Natural log of 2. Again, I get a decimal, and I'm not finished. I need to divide both sides by 4. So I'm going to say divided by 4, so it brings my answer down. So now I'm ready to say x is about 0.17. Okay, I'm going to check that to prove to you that it does work. So we've got 10. We see equals, so we go down to y2, 5. Again, e is right there in blue, so I have to hit second, natural log, and we are raised to the 4x. So we're going to go to the table. And I'm still on the last decimal I had, so I need to go back to the second window. When I look at that answer, I'm at 10, and I'm at 9.8, which would round to 10. Again, that decimal is not exact because we rounded ours off. This does work, so you need to know that the natural log of e, when I take it, is 1, but bring your exponent out front. Okay? So we're ready for the last problem on here. That's not what I meant to hit. Okay, we have e again, but my job is still to isolate the base. My base is still e, so I'm going to subtract 5. So I got 2e to the x minus 1. That should be 75. Okay, I'm not finished. E is not isolated. I still need to divide out this 2. And 75 divided by 2 should be 37.5. Let me double check that. Yes. Okay. Just want to make sure I'm doing my math right. Now, I'm at the same point I was. The base is isolated. I have done step 1, so I need to rewrite. But when I see a base of e, I'm not going to use the log. Log is only for bases that are whole numbers. It's not for e's. So my job is to take the natural log of both sides. Now watch when I do it over here, it's easy. Natural log of 37.5. No big deal. On this side, the exponent also needs to come out front, so I'm going to say x minus 1 times the natural log of e. Again, the exponent for exponent log property rules, it comes out front. This is going to be 1. Okay, that is going to be 1. So what that leaves me with is x minus 1 equals the natural log of 37.5. And what I can punch into my calculator so that I can get my answers, I'm going to punch in the natural log of 37.5. Nope, that is not what I... Okay, and I'm going to hit enter. So natural log of 37.5, but I need to add 1. So when I hit plus, it brings down my answer. So x is about 4.62. Okay, so when I go to my calculator and y equals, I've got 2e x minus 1, make sure I right arrow, plus 5. Okay, it's equal to 80. Oh, not 80. And I'm going to go to the table. I need to get my decimal, so second window, 4.62. Notice I'm at 79.6, which would round to 80, and then they would match. The closer I am, in fact, let me get off the screen, 4.6243. 4.6243. See, I'm just expanding that decimal when I go to the table. You see that I'm at 79.9 now. I'm getting closer and closer to being exactly 80. So the more of the decimal we use here, the better off my table is, but we're allowed to round to the thousandths today, so that's okay. Alright, so if I'm using logs and my base is a whole number, I'm using log, I rewrite. When I'm doing exponentials and my base is e, I have to take the natural log of both sides, and don't forget the exponent will come out front, and natural log of e is just 1. Okay, really important. Now, I'm going to make a second video for solving exponentials without log.